The axis of symmetry of the parabola f of x equals x squared plus bx is x equals negative b over 2. Here's the proof. F of 0 is 0 here. F of negative b, if you just plug negative b into the function, you get negative b squared plus b times negative b. Therefore, f of 0 equals f of negative b. So f of 0 is 0, f of negative b is also 0. 0 and negative b are the x-intercepts, so you just have to average them in order to find the midpoint, and you see that the midpoint is x equals negative b over 2. The axis of symmetry of the parabola f of x equals x squared plus bx is x equals negative b over 2, which we learned on the previous slide. Exercise A. Determine the axis of symmetry of the parabola f of x equals x squared plus 3x. Alright, so given that b equals 3, the coefficient of this term, the axis of symmetry is given by negative b over 2. So if you plug in 3 for b, you get negative 3 over 2. So you see that the axis of symmetry is at x equals negative 1.5. The axis of symmetry of the parabola f of x equals x squared plus bx is x equals negative b over 2. Exercise B. Determine the axis of symmetry of the parabola f of x equals x squared minus 4x. Alright, so here b is negative 4. So because x equals negative b over 2 is this point here, where this line is, we can plug negative 4 in for b, divided by 2, and we get that is 4 over 2, which equals 2. So the x value of this point is x equals 2. Here we have an equation for when a does not equal 1. The axis of symmetry of a parabola where a does not equal 1 is still x equals negative b over 2a. So we have proof here, and the proof extends out here. But essentially we have that the x-intercepts are 0 and negative b over a. Then you find the middle point there by averaging 0 and negative b over a, and you get x equals negative b over 2a. The axis of symmetry of the parabola f of x equals ax squared plus bx is x equals negative b over 2a. Exercise C. Determine the axis of symmetry of the parabola f of x equals 2x squared minus 5x. Alright, so we have an a value of 2, and we have a b value of negative 5. So, given that a equals 2 and b equals negative 5, in using this equation, we see that the axis of symmetry is x equals 5 over 4 here. The axis of symmetry of the parabola f of x equals ax squared plus bx is x equals negative b over 2a. Determine the axis of symmetry of the parabola f of x equals 4x squared plus 15x. We have an a value of 4, and we have a b value of 15. So if x equals negative b over 2a, we can plug in these numbers and we see negative 15, which is b, over 2 times a, which is 4, gives us negative 15 over 8. That is where the axis of symmetry is. Here we see that even when we have a c in the equation for the parabola, the axis of symmetry is still x equals negative b over 2a. You should note, though, that the points are not x-intercepts. So here we have 0, c and negative b over a, c, and that gives us the axis of symmetry of negative b over 2a. So here we have the proof that shows that 0 and negative b over a are symmetric to the axis of symmetry, and that this is the midpoint. The proof is here. H of 0 equals c, and then if you plug in negative b over a into the function, you get c at the end. So h of 0 equals h of negative b over a equals c. The axis of symmetry of the parabola f of x equals ax squared plus bx plus c is x equals negative b over 2a. Exercise E. Determine the axis of symmetry of the parabola f of x equals 2x squared minus 9x plus 3. Alright, so we have A equals 2, B equals -9, and C equals 3, although you see right here that we don't need this value at all because the equation for the axis of symmetry is just negative b over 2a. So we see that the axis of symmetry is 9 over 4, right here, 2.25.